thanks for the invitation by Professor Zhang Minghua. My name is Xiumian from Nanjing University. Together, Professor Li Hailong and Professor Wang Xinbing, they are information scientists from Tsinghua University and Shanghai Jiaotong University, respectively. So we three of us are the coordinator for the DDE knowledge group. So I would like to briefly introduce what we have done and what our next steps. So as introduced by Professor Zhang, so the DDE, one of the goal of the DDE would like to share the data with the community. So before do that, we need the knowledge graph or the ontology for the computer to understand us. So that's the next, please. So that's the reason why we do this kind of work. So I will skip off this slide. Next, please. Yeah, as designed by the DDE, so there will they have five parts. So called to achieve the DDE goal. So the so-called big knowledge. This is one of the basement for the DDE. So that together with the big data, big science, and big media, this is the for. So we will all of this. So by using of big platform, so we will want to achieve to share the geologic data with everybody that we are using. So next, please. So as you know, so our real goal for the DDE knowledge is to compile data and by using the data and searching the data and automating the data. So to do this, so we need to construct our DDE knowledge. And also, we would like to provide, based on knowledge, we would like to provide surveys for the DDE group. So for this, so we designed the DDE knowledge editor, DDE knowledge extractor, DDE knowledge provider, DDE knowledge embeddler. So this will be totally designed by the information scientists. So next, please. So we for the DDE knowledge construction. So let's say we divide our process by 4 steps. Now we are on the way on. So first time, so we by human being or scientists, we would like to build our knowledge system. This is totally constructed by geologists or by scientists. And then also different with the knowledge graph designed by the information scientists. We would like to build up the knowledge lure. I will introduce this later. And then based on knowledge system plus knowledge lure, we would like this is more or less similar to the ontology, let's say ontology. And then for this is more or less by this, sorry, I should, the first step and second step. So many construct by the geologists, let's say scientists. And then for the third step and fourth step, these steps will be mainly led by the information scientists. And these were so-called ontology construction and knowledge graph platform design. So all of these steps, so this is on the way to compile our DDE data. So next, please. So what we have done, so as introduced by Professor Zhang, so DDE initiated, let's say until now, established 19 working groups, cover many are geosciences, let's say, so solid earth science, including this of so geology, geophysics, geochemistry, and hydrology, and also mathematical science, this kind of geologic mapping. So these sub groups. So each group will lead by international leader and also our Chinese partner as well. So next, please. So we also establish a platform so-called Geoscience Knowledge System. This, by entering into this online platform, we can edit and review the knowledge system. Next, please. So also we can edit as so the construction, the figures like this. Next, please. This what we have added and into the platform. So totally we have 47,676 knowledge nodes has been created by the experts. So this is the numbers below the groups will be the nodes which we already input into the platform. So I'm sedimentary geologist. I'm the Chinese co-leader for the sedimentary group. So for this group, we established 2,738 nodes, knowledge nodes. Next, please. For this, so why we established this platform? Because we want to easily to construction and sharing mechanism. So we can construction easily, and so we can share it easily. And also all nodes will be reviewed by the peer review. Now, some of the groups are sending the knowledge system to the for peer review. Next, please. In our knowledge system, so we have we differentiate the nodes by conception, let's say word or property or relationship or rules as well. So this is unique. So this is conception, property, and the relationship. This is the same as the information science. So, but we think the rule is also important for our data sharing. Next, please. So each node, knowledge nodes have a definition. So we can, for example, like Waxstone, we have a language, we have a subject, we have definition, and we have the source for this definition. So let's say reference. So all these now what should be input on the platform. Also, these knowledge nodes will need to be reviewed at least 2 reviewers. Next, please. For example, why we introduce the knowledge rule? For example, we have a carbonate rocks and we have dorstone, limestone, calcareous dolomous limestone. Why we have this classification? So we here, for example, at least we apply 5 rules like carbonate content if less than 10, larger than 90, then you get different carbonate logs. So this is important for our classification. Next, please. So for example, we have this is for designed by the geologists for carbonate logs. So we can this is the relationship, and this is another node. So this we will put the relationship, and then, for example, if we have this, then we will put the so like circle. We will put this is a lure. So for this, or relate or property. This next, please. And also we have definition for each of the terms. Next. So for example, we just quickly take the sandstone. This is our let's say knowledge system, and then if we transform for the knowledge graph, which is like on the right side, and the next piece. So this is a sandstone classification knowledge graph. Next, please. Yeah, because we have different classification, and then if you get the data, next, please. Yeah, can you click on the play, and it will automatically show. Yes. So I'll show you that by using of this knowledge graph, we will if we get the data like quartz, feldspar, and lithite. So this kind of data, so you will get the ratio of this, and then by using of the knowledge graph, so clicking different classification, you like Dickinson, like Kazanti, or like Dolan, or all kind of classification. If you have knowledge, then you will automatically show what you data tells the name of the sandstone type. Okay, next, please. Skip of this, the next, yeah. So until now, so we have some difference between our DDE knowledge system or knowledge lure and the knowledge graph. So currently we only on the way of step 1 and step 2. So if we want to get knowledge graph, we need to do more. So we need to information scientists have from them. So next, please. So format. So for our knowledge system or knowledge tool, this is created by human, not machine readable, like identifier and namespace. Next. And scope. The nodes are not cover all concepts of solid earth science, because this is belong to our knowledge by human being, but we need to also next. This is so we need design the uploading platform. So now, so we need new knowledge editor platform. So we are this leading by Professor Liu Hailong. So based on Plotex, this software. So as a unique and persistent identifier, using ontology language make DDE knowledge accessible for users. So this is Liu Hailong is Professor Li, coming from Tsinghua University. He will lead this this kind of work for the DDE. Next, please. Also, they will design knowledge so extractor, so like using the DDE Scholar. Now DDE have another product so-called DDE Scholar. This is lot of, this is the paper, over 1 billion, 1 million of paper, scientific paper on the platform. So this is only for the geoscience. So over 1 million for those. Next please. So next time, so we would like, they will leading by Professor Wang Xinbing. So they will want to exchange concept entity relationship from the scientific papers, and then creating knowledge graph. So this is the we will get additional nodes from the automatically from the scientific papers. So this time, so the if we finish this, so we will get a new item from the papers. So now we are on the way to do this step to explore our terms. Next, please. Last, I would like to show that recently the DDE will propose 2 special issues on the so-called on the DDE ontology or knowledge systems. One is the geoscience frontier, Junior. The other one I would like to propose a special issue from for the computer and geoscience. So this is the title. The proposed title will be DDE Geoscience Knowledge System, Ontology, and Knowledge Graph for data-driven discovery. So welcome everybody from the world to submit manuscript for that. Next, please. Yeah. That's my talk. Thank you.
Thank you very much, Professor Hu. Discussion, please.
Hi, it's Rachel Heaven from BGS.
Hello.
Go ahead.
Can I ask what methods you're using to extract the knowledge graph from the literature?
You mean they have this lead by Professor Wang Xinbing from Shanghai. He would like to. He have a plan for. Already have a papers on that. They would like to get the term from the title from abstract firstly, and then it also include the keywords. So they will and also by use compare the term which we already input. So they if they have a new ontology or new terms occur, they would like to also we our human being scientists will review them, and then if they are new or if they have the terms which we never find out, so we would like to put them into a new term for this subject. Yeah.
Okay, so you're not using a named entity recognition tool. It's just looking at keywords in the abstract. Is that right?
Yeah.
Thanks. So just to let everyone know, we're building machine learning models for named entity recognition for geological ages and rock formations, and yeah, we've got plans to build more tools that could extract lithologies. Or
similar. So they will use like they already have a built the entity recognition model, and so they will change the model and develop the model much precisely. Yeah.
Thanks.
It's Nick here. There's been a couple of named entity recognition projects with geological literature in Australia. So the CSIRO, the National Research Agency, has done some work with this kind of thing with a couple of the geological surveys, in particular Geological Survey of Queensland. So yeah, it'd be good to, I'm not involved in that work directly, but it would be good for those organizations to share notes on their precision. Yeah.
Yeah, thank you. That would be nice. If I'm sure that this is for machine, for the intelligence science. This is the one of the front end area. Yeah.
Additional discussion, please.
I'm curious in this bottom-up approach whether you are also building the ontology bottom-up or just instances of the ontology. So will you be adding concepts to your knowledge graph or just new instances of concepts? So if you understand what I mean.
We have two steps. Firstly, we will export, let's say, from bottom up. Because we only, for example, for sedimentary ology, we only, for human being, we only put that's a lot, 2,000, over 2,000. But I'm sure that that's not enough. That's not all. So we will by bottom up. So we will find if we have a next some word, or if you have a more words. So this is the first step. And also we will, for knowledge graph, so we will also use as you mentioned that the example. So we will do, for this is for the, you need to build up let's say the for knowledge graph. So this is the last step. Yeah.
Thanks.
Sorry, I'm not the expert on that, but Professor Wang Xinbing was not here. Yeah.
No problem. Thanks very much.
Thank you.